All right, in this lesson, we're going to be talking about similarity in right triangles. So there's some pretty cool features about the right triangle that brings out similarity and special ways that we can solve. One of the first things we're going to talk about is the right triangle altitude theorem, which says that if the altitude is drawn to the hypotenuse of a right triangle, it creates two triangles that are similar to each other and to the original triangle. So that's 3 total, and I've drawn them out this way. So this is basically saying that if you were to draw an altitude from the right angle down to the hypotenuse, that's what the to the hypotenuse means. Remember we defined altitude in Unit 5, Day 1, I believe. And altitude is any segment that drops from the vertex of a triangle and is perpendicular to the side across from it. So in the right triangle specifically, we're going from the right angle down to the hypotenuse to create that perpendicular relationship. When you draw this altitude, it creates 3 similar triangles. You have the original triangle, the full one, right here. You have the one on the left that's created on the left side of the altitude, this right triangle. Then you have on the right side of the altitude the kind of brick designed one. So all 3 of these triangles every single time will be similar, as long as it's a right triangle to begin with and you draw an altitude from the right angle down. So what we're going to be doing is taking that idea and practicing it. So what we're going to be doing is looking at determining what the corresponding sides are. So because the triangles are all similar, that means that the corresponding sides should all be proportional like we've seen before. So all that we're really going to do is practice identifying what sides are proportional or corresponding to other sides in the other 2 triangles. Okay, so our first thing that we're going to do is take a look at this triangle that they've shown, right? It's a right triangle. ABC is a right triangle. They've drawn an altitude from the right angle down to the hypotenuse. So we're going to take each of these triangles and redraw them. So I've actually done that. So this is the little one. I've drawn it in the same orientation as the one up here. You can go ahead and label the vertices if you want to, A, C, D. That actually probably will be better. It's hard for me to write because I'm doing this on my laptop instead of the smartboard. So if you label A, D, C, that'll make it easier for what we're going to do over here. So that's the little one, and then we have the medium-sized one, which is right here, which is A, B, D. So you can go ahead and label the sides there. And then, of course, we have the full-size triangle, which is how it all started. We have the A, B, C kind of orientation right here. It'll be a lot easier for you to work with these if you draw them in the same orientation as they were in the picture. Just kind of separate them and draw them off to the side. So this question over here wants to know what sides correspond to segment AB, CB, and CA. Now, I put this little blurb right here, and you should add that to your notes as well. These sides right here are referring to the sides in the full triangle. Okay, so whenever they give you a question like this where they're asking what sides correspond to blank, the side that they give you will always be in reference to the full or big triangle, the biggest triangle. And so you're just matching it to the corresponding sides in the 2 little ones that are created after you draw the altitude. Okay, so that's what this was kind of talking about. These questions are in reference to the bigger or full triangle. So the way that we're going to do this is just like we learned in the past lesson. We're going to match small to small, medium to medium, and long to long. Now I know we don't have all of the side lengths shown here, so we're just kind of going to use observation to decide what's the short leg, what's the medium leg, and what's the hypotenuse. Because remember, the hypotenuse is the longest side in a right triangle. And we're going to go through each one of these triangles using our observation. We're going to label the shortest sides with an S, the medium length sides with an M, and then the longest side, the hypotenuse, with an L. And that'll make this process that we're about to do a lot easier. So in this triangle right here, if you look at this diagram, in case you drew this a little bit wonky, you can look at the original diagram here. Clearly the short leg is CD, so I'm going to label that with an S. Oops. There we go. In the medium triangle here, the short leg is a D. It's shorter than this one. You can kind of eyeball that. So that would be the side right here. And in the full triangle, the shortest side is CA on the top. Okay, now we're going to do the medium length side. So again, back to the small triangle, the medium leg is this one right here. So it's going to be M, which leaves the hypotenuse to be the longest. And then over here, the medium length side is DB. And then obviously the hypotenuse is the longest. And then the full triangle, the medium length side is AB right there. and then the longest side is the hypotenuse. So all we're going to do really is, looking at this question, we're going to figure out, is AB a short, medium, or long side in the big triangle, and then match it to the short, medium, or long sides in the other two. So AB in this triangle, if we look over here, AB is right there. That's the medium length side. Okay, so I'm going to find the medium length sides in the other triangles and just write them down. So over here, the medium length side was DA. DA. And then in this triangle, the medium length side is DB. There you go. All right, now we're going to move on to CB. In the big triangle, CB is the hypotenuse, so that's going to be the longest side in each triangle. So I'm going to find the longest side in the other two, because I've already taken care of this one. Excuse me. So then in this triangle right here, the longest side is CA. All right, so I'm going to go ahead and write that down. CA. There we go. And then in this triangle, the longest side, excuse me, is this one right here, which corresponds to BA. Sorry, yeah, BA. BA. There we go. All right, so again, you're just checking to see what side in the bigger triangle you're looking at, and then you match it up with the sides in the other two triangles. So in this one, the CA, which is right here, that's the shortest side, so I'm finding the shortest sides in the other two triangles. And so over here, the shortest side in this triangle is DC. And then the shortest side in this triangle is DA. Okay, so that's all you really have to do. Redraw the triangles, label the sides, short, medium, long, so they're all corresponding. And if they ask you to find those corresponding sides, you start with the bigger triangle and then match up to the other two. All right, so that's really just kind of diving into the idea of what happens when you draw that altitude. Now we're going to be talking about the primary idea of this lesson, is solving for what we call the geometric mean. So on lesson 2, when we were introducing proportions, I told you that the parts of a proportion have special names. We had the extremes and then the means. This is where mean comes back in as a vocabulary word. So the geometric mean, the definition of a geometric mean, sorry. Can you move? Thank you. The geometric mean is the value of x where a over x is equal to x over b. So this is a formula you have to remember. This is the formula for finding the geometric mean. If you remember from day 2, the geometric mean, or sorry, the mean in general for a proportion is in this position and this position. We call those the means. So if they want you to solve for the mean, you're going to put an x in both of those positions. It's going to be the same number in both positions. And then they're going to give you two numbers, like these examples right here. They're going to ask you to find the geometric mean of two numbers. That's where you put, or you replace a and b with those two numbers. And then you just cross multiply to solve for x. So do memorize this little formula here, and then they'll give you a and b. You plug them in and solve. So for instance, this one right here, 9 and 4, if I'm trying to find the geometric mean, I'll say that 9 will represent the a. X is the one of the means. I don't know. I don't know this mean either. And then the other number they gave me was 4. Right? So again, when you have a proportion like this, you cross multiply to solve. So x times x is x squared. Sorry for my sloppy handwriting. And then 9 times 4 is 36. So we have this right here. Okay? And then of course we don't want x squared, we want x. So to solve for x, we have to take the square root. And then the square root of 36 is just 6. Technically it's 6 and negative 6, but we don't want the negative one, right? So it's just going to be x equals 6 as your solution. And that's really all you have to do, and it's a straightforward question where they just want to know the geometric mean between two numbers. So let's say we were doing 4 and 5. So again, you put the 4 and then over x equals x over 5. You're going to cross multiply. X squared is equal to 20 this time. So 20 is not a perfect square. So when you take the square root, you're going to get the square root of 20. And remember, when you have a square root that can be simplified, you have to simplify it or you will not be fully correct. So 20 factors into 4 and 5, and 4 is the biggest perfect square. So that would be 2 square root 5 when you simplify. You need to brush up on that. Go ahead and Google it or something to review how to simplify radicals. But this would turn into that when you are simplifying, and that would be your final answer. Okay? And then another example, 9 over x equals x over 8. Here we go. Cross multiply, you get x squared equals 72. Again, not a perfect square, but we can go ahead and simplify that when it turns into a square root. So we have x equals the square root of 72. And then 72 is equal to 36 times 2. 36 is the biggest perfect square. That's a factor of 72. So that would simplify to 6 square root 2 when you simplify that radical. And then lastly, 3 over x equals x over 7. X squared equals 21. And then 21 is not a perfect square, but it's also not a square root that can be simplified. So you just leave it as square root of 21. So if you can't simplify the square root, just leave it alone. All right, so that's just your basic, straightforward example of finding a geometric mean between two numbers. So please make sure you memorize that formula and how to use it. Now, if they ask you to find a geometric mean in the context of a triangle, instead of just giving you two numbers, instead they did give you a diagram, that same diagram we saw before. We have a right triangle and then an altitude drawn through. If they give you this scenario, they can also ask you to find the geometric mean. Now, the way that you're going to do this is by using one of two formulas. So there are two different ways that they can label or give you information in these diagrams. The first one is called method 1. The altitude itself that they draw is the geometric mean of the two segments of the hypotenuse. So when we drew the altitude, it split the hypotenuse into two different parts. The altitude itself, whatever is the value or label here, that is the mean, the geometric mean. So in order to write a formula for this, you'd have to take one section of the hypotenuse, so B, and then that would be over the altitude because the altitude is the geometric mean. The altitude would also go here, and then the C, the other section that you're finding the geometric mean of, goes on the bottom of the second fraction. So it's just like this formula, but A and B, to find those numbers, you're using the two sections of the hypotenuse. So if you're one who likes to memorize proportions, go ahead and just memorize this formula. However, my classes in past years have helped me name a special rule that I have used in the past that's a little bit more visual rather than just memorizing a formula. I use a visual representation to help me write the proportion. And my students call it Splash Mountain to go along with this rule that I came up with, the roller coaster. They chose another amusement park ride that kind of mimics what we're going to be doing here. So the little trick that I use, because I hated memorizing formulas, was to draw this little arrow track. It looks like you're going up and then you're going down again. So it's kind of like that Splash Mountain idea. These arrows can be drawn in either way, so you can go from left to right or right to left. You will get the same result either way. But since we typically read from left to right, that's why I have the arrows going this way. So basically what this does is it trains you how to write the proportion. The arrows tell you each side of the proportion. So this arrow represents one ratio, B over the altitude, and then this arrow represents the second ratio, altitude over C. So it's this formula, but kind of visually notated with these arrows. B over altitude equals altitude over C. And that will consistently work for you every single time that they have this scenario. All right, so you use this formula or use that trick when you have this scenario, when the altitude is labeled and you don't have either of the other two sides labeled. You just have the altitude and the hypotenuse. Okay, that's method 1. So let's take a look at this one. That's what's happening in this scenario. I have the hypotenuse has information on it and the altitude has information on it, but I don't have any information on the other two legs. So this is where I would use Splash Mountain. Okay, so my proportion, either using the one that you memorized or using the Splash Mountain trick, be 5 over 2 equals 2 over x. 5 over 2 equals 2 over x. So once you write the proportion again to solve, you would just cross multiply. So 5x equals 4. You divide, x is equal to 0.8. There should be an equal sign. Oh no. X equals 0.8. There we go. All right, now that's example or method 1. You could also have method 2, which does, sorry, look more complicated. So for this one, the leg is a geometric mean of the full hypotenuse and the segment of the hypotenuse that's adjacent to the leg. So this one's more words. It's a little bit more complicated to understand. This formula, I know in your notes this has a C. If you could switch it to a B just for this example here, it could technically be C. Sorry, the value here could be replaced with a C, but the only reason why I want you to change it to a B is because of the leg that I'm using here. So again, this changes depending on which leg you're given. You could be given this one right here or this one right here. And it depends on which leg you use that tells you which one of these two parts you use. So go ahead and change that to a B, because in this example that I've illustrated for you, I've used the leg that's closest to B. Okay? So again, in this situation, which sometimes people refer to as the leg rule, this is where you're given the leg, one of the legs, but not the altitude. That's the difference. Over here, you're given the altitude. Over here, you're not given the altitude. You're given one of the legs instead. So for this proportion, if you want to memorize it, they're saying that the leg is the geometric mean, so that goes twice here and here, just like in our formula above. The other two things that you're going to be using is the full length of the hypotenuse and then the segment of the hypotenuse that's adjacent to the leg. So that's where it could switch. If you're using this leg right here, the adjacent part is C, but if you're using this leg, the adjacent part is B. So it depends on which leg you're using to tell you which part of the hypotenuse you're using. Right? So it's full hypotenuse divided by the leg equals the leg divided by the section closest to it. All right. Now, when I was younger, again, I really hated memorizing formulas, so I invented this Splash Mountain rule, and then I also invented this roller coaster rule that really worked well for me. Now, this rule does not work well for everybody, so I'm just going to show you, and you don't have to use it. You can memorize the formula and just kind of get the muscle memory. But this trick can help you avoid the memorization and just make it real quick and simple to get that illustrative method here. So what I did is basically whatever leg they gave me, whether it was this one or this one, the leg that they gave me, I would highlight that. All right. Now for a roller coaster, the launch roller coasters, you need as much momentum or space as possible to get the most amount of speed before you go into a loop. So what I would do is I'd start over here as far away from the leg as possible, because that's what I need to loop over. That's the geometric mean. So I start as far away as possible, and I pretend I'm on a roller coaster. I go shooting forward. I do my loop around the leg, and then I end right here. So I draw this little loop right here, and that helps me know how to write the proportion. The track that I just traced tells me what I write. So it's C plus B, the full length of the hypotenuse, over the leg equals the leg over B. That's exactly what I have right here in the proportion. And this will work every time as well. You start as far away from the leg as possible, you trace the hypotenuse, draw a loop, and then come down again, and that track that you just traced is how you would write the proportion. All right, so to illustrate again with this example, if you were to use the roller coaster rule, the leg that they gave me is not this one anymore, it's this one on the right-hand side. So I trace that one. I start as far away as possible right here. I trace the hypotenuse, loop the leg, and then come down again. Okay. Now I've drawn this illustration, right? And now I'm going to draw the proportion, or sorry, write the proportion, and you could do it either from the illustration or after memorizing. But basically, if I follow the track, it's y plus 2. Y plus 2 over 8 equals 8 over 2. Just like that. Okay. This is a proportion. If you cross-check with the rule over here that I've printed, you'll see that that matches, right? And again, in this illustration where I had B here and C here, this is just the kind of inverted representation of this formula where they use this leg instead of that one. So again, you could either memorize or draw the illustration. Once you write the proportion, you cross multiply again. So I would have 2y plus 4 equals 64. And then you would solve algebraically. You would subtract the 4, divide by 2, so that would leave you with y equals 30. Oof. Okay. That was a little rough. Let's try that again. Y equals 30. There we go. All right, so definitely this one's simpler to work with. This one I know can be complicated. If that little illustration I was drawing with the roller coaster doesn't work for you, then you can just ignore it. You can just memorize this rule, how it's full hypotenuse over the leg equals leg over the section closest to the leg. Memorize that and move on. That's totally fine too. All right, so that's just the basics of understanding those. On the other side of the page, we just have a bunch of examples. We're just going to practice, practice, practice all the different kinds of scenarios we could see. There are a couple in here where there's factoring. You need to know how to do that too. It works for a lot of different scenarios with these. All right. So what I'm basically going to do is look through and see, is this going to be method 1 with the splash mountain or method 2 with the roller coaster roll? Once I decide which method to use, then I'll be able to move forward with writing the proportion and solving. So taking a look at this example right here, I notice that it's the altitude that's labeled, not one of the legs. So this is going to be method 1, the splash mountain. So you can go ahead and draw your arrows if you like that illustration, or you can check back to see what the formula looks like. So I'm going to use this section of the hypotenuse over x equals x over this portion of the hypotenuse. Now this is where you have to be really careful. You have to be paying attention. This bracket right here is telling you the full length of the hypotenuse. So you would not do 12 over x equals x over 27, because 27 is not referring to this section. It's talking about the whole length. So in order to find the other piece of information I need for the proportion, you're going to have to do 27 minus 12 to get the remainder of this little section right here. So when you do that, that's actually 15. So that's the number that you're going to be using for the proportion. So they will do that to you, where they don't directly give you all the information up front. So you have to make sure you're looking and being careful that you're using the correct information in your proportion. So once you go ahead and deal with that, we're going to do 12 over x equals x over 15. So 12 over x equals x over 15. Then once you set up that proportion, you can go ahead and cross multiply. So you would get x squared is equal to 180. And then of course you'd have to, oh my gosh, I'm writing way too big. X squared is 15. X squared is equal to 180. So you guys are definitely going to have to do the square root here and then simplify, because 180 can definitely be simplified. So I'm going to have x is equal to the square root of 180. So if you go ahead and practice your simplifying of radicals, you'll find that the biggest perfect square that is a factor of 180 is 36. So the square root of 36 simplifies to just 6, and then the other factor is 5. So that would be your final answer for x right there. Question done. All right. Move on to this one. We notice again it's the altitude that's labeled, not the legs. So I am going to be using splash mountain again. All right, so it'd be x over 10 equals 10 over 25. So x over 10 for the first arrow, and then 10 over 25 for the second arrow, and then I cross multiply. So I'm going to have 25x is equal to 100. I'm going to try to minimize the amount of writing I'm doing because I'm struggling here. But when you cross multiply, you guys should be able to do that algebra. You get 25x equals 100. When you divide by 25, you should get that x is equal to 4. Okay, so those are your pretty straightforward method 1 situations there. Now this one right here, this is different because the altitude is not labeled. Instead of the altitude, we have one of the legs. And again, when you're trying to figure out whether it's an altitude or a leg, you want to be looking at the full triangle right here. You want to look at the big picture. You either have the line down the center, well not center, but down the inside of the triangle is labeled, or it's one of the legs of the big triangle is labeled. And that's what's going on here. So the altitude, I have one of the legs. So this is where you're going to be using the roller coaster rule, or just memorizing that proportion and applying it. So if you use the roller coaster rule, again, I highlight the leg. I'm going to start as far away as possible. This is my launch, loop, land. I just came up with that right now. That's cool. They all start with L. So you have the launch part of the roller coaster, the loop, and then the land. Sorry, I did just come up with that. And then you're going to be using the track of the roller coaster to write your proportion. So again, the first part of your proportion is this part right here. So I'm going to add those two together. So I'm going to have x plus 7. We typically write the variable first. So I'm going to write it as x plus 7. All right. over the leg, 12, because the leg is a geometric mean, so it goes here and here. All right, so this part over 12, and then 12 over x. All right, once you set up your proportion, now I'm going to cross multiply and solve. So I cross multiply, I'm going to get an x squared plus 7x equals 144. So hopefully you should notice here, this is a scenario we had very similar to last time. If you guys have an x squared, an x, and a constant, that means you're going to be factoring to solve. And every time we factor to solve, especially in geometry, you have to make sure that both of your answers make sense. And in this scenario, more often than not, one of them will fail. So please make sure you're checking your answers. So before we can factor, this number needs to be moved over. So to really be x squared plus, there we go, 7x minus 144, because you need everything on the same side. 1. There we go. All right, so remember to factor trinomials. All right, this is a trinomial with a leading coefficient of 1, so I'm going to go ahead and use the shortcut method that you guys probably heard of before. So I need two numbers that multiply to get negative 144, but add to get 7. I'm only going to draw this for this example, but know that I do this process every time. So multiplies to get negative 144, adds to get 7. Now this is a little bit more abstract because you're used to factors 12 times 12. You're not probably that familiar with the other factors that get to 144, so you might want to work with your calculator a little bit to divide and see what's going on. But ultimately, the two numbers that do that you're going to be interested in are positive 16 and negative 9. Those two numbers multiply to get negative 144, but add to get 7. So with those two numbers, you go straight to your factor. So you're going to have x plus 16, because the 16 is positive, and then the other factor is going to be x minus 9. So that's it factored. Now in order to solve, again, you take each of your factors, you set them equal to 0. So one of my x's would be negative 16 and the other one would be positive 9. Okay, now this is where you have to analyze to see if your numbers make sense. If you were to take negative 16 and plug it in right here, you'd have, for this side length of a triangle, you'd have negative 16 plus 7, which would still be negative, and x serves as a side in the smaller triangle right here, which can't be negative either. So in any situation, this negative number does not work for you. When you plug in the 9, it's positive and it works out. So you're going to get rid of the negative 16 and only say that 9 is the answer. Okay? So yes, factoring is still a possibility in these. You just use either method 1 or method 2, and then when you cross multiply, it may work out that you have to factor. So just keep that in mind. All right, this one over here, you'll notice that the altitude is labeled instead of one of the legs. So this is another Splash Mountain. It is kind of sideways, so the mountain idea of going up and then down isn't quite the same. So we're kind of going sideways and then out. But the arrow rule still works the same. You draw an arrow from this to the altitude and then from the altitude to the other section. And we're going to write the proportion the same way. So it'd be x plus 5 over 6 equals 6 over x. X plus 5 over 6 equals 6 over x. Right? When you cross multiply, you're going to get x squared plus 5x equals 30x, but I need the, 36x, sorry. When you cross multiply, x times x is x squared plus 5x equals 36. There we go. But in order to factor, you need the 36 on this side. So I'm going to do both of those steps in one. So I'm going to cross multiply x squared plus 5x, and then I'm going to just automatically move the 36 over by subtracting. Just minimize my writing because it's hard to do without the smartboard. All right, so this is what I have after I cross multiply and then move the 36 over. So again, for factoring, I would do this trick over here, which I'm not going to write, but you need two numbers that multiply to get negative 36, but add to get 5. So draw that little X if you want to, or a little box. There are a couple different ways you can do that. But the two numbers that multiply to get negative 36, but add to get 5 are 9 and negative 4. So those are the two numbers that you're going to use in your factors. So x plus 9 and then x minus 4. And then again, once you've factored, you would set them equal to 0 and see what actual x values you would get. So I would have x equals negative 9 and x equals positive 4. Again, check your answers. If you take negative 9 and plug it in right here, that would be -9, and x represents the side of a triangle. You can't have a side of a triangle be a negative value. So this number is off limits. That's not going to be a valid solution. So the only one you want is 4. Right? And again, if you check 4 too, it gives you positive values that work out with the corresponding ratios or the scale factors. So that's the valid answer that you would want to keep. All right, so those are really the only 2 that I have factoring for. So just make sure you do realize that factoring still shows up in these kinds of scenarios. All right. All right, now this is an interesting question because we do not have an altitude labeled, which indicates that we will be using the roller coaster rule, but what's interesting is that they've given us both of the legs. This is not typically going to happen. You're only allowed to use one of the 2 legs for the roller coaster rule, so it's up to you guys to figure out which one of these 2 would be most appropriate. So remember the roller coaster rule, or the proportion that you're going to be using, says you have the full hypotenuse over the leg equals the leg over the portion of the hypotenuse that's closest to it. So if you take a look at the side or the leg labeled 10, in order to do the roller coaster rule, you'd go across the entire hypotenuse, which we know as x. You'd loop the 10 and then come down again. We don't know what the section is, and that's the section you would need if you were going to do the proportion using this leg. So I can effectively rule this side out because it doesn't have enough information to use that side. Okay, so instead I'm going to be using the leg that's labeled 7, and I'm going to use the roller coaster rule from that perspective. So I go as far away as possible, I trace the hypotenuse, loop, and then land. All right, or you can just use the proportion instead of drawing the loop. But again, your ratio is going to be the full hypotenuse, which is just x. Notice that you have the bracket here. I know that they have x and 6 here, but the hypotenuse is not x plus 6. All right, the whole hypotenuse is x. The x already takes the 6 into consideration because it has the bracket from end to end. So please do not add the 6 on when the x is already expressing the full length of the hypotenuse. You would double count the 6 and that will throw off your answer. Okay, so the full length here for the launch here for the roller coaster is just x for the hypotenuse, and then over 7 is equal to 7 over 6. Just like that. Cross multiply, 6x equals 49. You're going to divide by 6, and you would get 8.2. Rounding. So whenever you have I know it's like 8.16 something repeating or something like that. When you guys have a decimal like that, just round to 1 decimal point, as long as it doesn't round up to a new whole number, which I'll show you, I think, in this example here. There's an interesting rounding scenario that I'll tell you that's slightly different, but if you can safely round up without affecting the whole number, go ahead and do that. All right, so that's that one done. Now this is another interesting question because we have 2 variables. When you have 2 variables, you have to think very carefully to see if one of the variables depends on the other. So let's take a look at x right here. This is a part of the hypotenuse. In order to solve for x, I would use, well, let's see. If I tried to use the roller coaster rule to solve for x, I would have to use this leg, and I would go around like this and then down again. So I have all the information right here within the loop to solve for x. I didn't even need y when I did that, right? So x can be solved for independently from y. But if you try to solve for y first, this is the altitude. So to find the altitude, you have to use method 1, which is splash mountain, which would have to be 8 over y equals y over x, something we don't know at the moment, right? So y depends on x. So you're going to have to find x first. So when you see that relationship where one is dependent on the other, you have to find that first variable in order to solve for the other. So I'm going to go ahead and solve for x first because I have enough information to do that. So to solve for x, I'm going to be using the roller coaster rule, which means I'm using this leg right here. I'm going to start as far away as possible. I launch, loop, and then land. Okay. The proportion I'm going to be using is the full hypotenuse, x plus 8, over the leg that I'm looping. Oops, what? That was weird. X plus 8 over 12, and then the second part of the proportion is 12 over 8. right? Then you would cross multiply that. You would get, excuse me, 8x plus 64 is equal to 144. You cross multiply. And then I know you guys can do that algebra. You would subtract the 64 and then divide by 8. So for this example, you would get x equals 10. As long as my math is correct that I jotted down. Let me double check. Yep, you get 10. All right, so now that I know this information, I can put this into the picture. Now I have enough, good grief, I have enough information to solve for y. So again, to solve for y, which is an altitude, I'm going to be using method 1, the splash mountain method. So I would draw my little arrows. So do 8 over y equals y over 10, now that I know that information. So 8 over y equals y over 10. I would cross multiply. I would ultimately get y squared equals 80, which means I would have to take the square root. I'm going to skip a step. You guys shouldn't skip steps. I'm just having trouble writing here. So you would get y squared equals 80, and then you take the square root, so you get y equals square root of 80. Again, you need to explore to see if there's anything you can do to simplify, which you can. 80 is the same thing, or it can be factored into 16 times 5, 16 being the biggest perfect square. The square root of 16 is 4, so this would turn into 4 square root 5 as your final answer. Okay, so sometimes they do have two variables you're solving for. Sometimes one is dependent on the other, but that's not always the case. But if you do notice that one needs the other variable first, please make sure that you solve for them in the correct order. All right, 4 more. This one only has one variable. Instead of giving me the altitude, they have given me a leg. So this means I'm going to be using the roller coaster rule. So I'm going to start as far away from the leg as possible, which is right here. One of the two, the vertice that is not, the vertex, which is not touching the leg that you're going to be working with. You are going to launch across the hypotenuse, loop the leg, and then land right here, the part that's adjacent to the leg. And then we're going to write our proportion. So this part right here, the launch, that's the full length of the hypotenuse. They've given us a bracket to tell us the full length is 25. Again, do not do 25 plus c, or 25 minus c, or 25 times c. This c is completely separate from the 25. It's already been included in the 25 when they drew the bracket here, right? So this full length is 25 over the leg, which is 18. And then the second proportion is 18 over c. Cross multiply, you would get 25c equals 324, I think. Yeah, 324. And then when you divide, you would get c equals 12.96. Now this is different from the other scenario where I was telling you could round decimals. If you were to round this, the 6 would round 9 to a 10, which would round this up to 13. I don't want you rounding that much where it changes the whole number part, or the number over here besides the decimal. I don't want you to change it that much. It kind of messes up the accuracy. So if you can round up without affecting this number, go ahead and do it. But if you can't, then just leave the decimal the way it is. You could also just write as a fraction if you wanted to. Either way is fine. Here's another example where there are two variables. Let's check to see if they are dependent on one another. So to find y, which is the altitude, I would have to do the splash mountain method, which means I need to know this section, and this section, which I can find. I don't currently have anything written here, but I know the full length is 25 and this is 9. So to find this missing piece that I need, I can do 25 minus 9 to find that section, which is going to be 16. All right, so I have everything I need to find y using method 1. X is on a leg, so I would be using the roller coaster rule. So I have the full hypotenuse over x equals x over 9. Again, for that one, I have all the information too. So these are not dependent on one another, so you guys get to pick which one you want to solve first. And you don't have to use one to help you solve for the other. So that's different from the question right above it. So say you wanted to start with y, because you like method 1 better. right? Let's say you wanted to draw the arrows. And again, you can draw the arrows in whatever direction you want. You can go this way, you can go that way, whatever just makes more sense to you. So when I write the proportion, it's going to be 16 over y equals y over 9. 16 over y equals y over 9. 16 over y over 9. There we go. Then you're going to cross multiply. You would get y squared equals, what number did I get here? The 144. So when you do that, it'll actually work out to be a nice whole number for you. When you do y squared equals 144, hopefully you guys remember that 144 is a perfect square. So when you take the square root of both sides to solve for y, you get that y is equal to 12. Okay. Now let's say we're switching to x. So again, x is a leg. So we're going to be using the roller coaster rule. You go as far away as possible. You're going to launch across the hypotenuse, loop the leg, and then land right here to the part adjacent to it. So again, the proportion we're going to write is the section, which is 25 from end to end. That's what the bracket means. So 25 is the full length of the launch section. And then I'm going to go over x is equal to x over 9. That's how I write my proportion. Then I cross multiply, so I get x squared is equal to 25 times 9 is 225. Another perfect square. So when you do the square root of 225 in your calculator, it is a perfect square, so x comes out to be 15. So both of those ended up being whole numbers when they simplified. Okay, all right, just two more. So for this one right here, it's the altitude that's labeled, not either of the legs. So I will be using Splash Mountain. So I'm going to be going up like this and then down again. So what's interesting in this example is that I don't know this section right here, but I do know this one. And it's similar to this question that we did up here, but this was a number, so I could just subtract and find another number. Over here, this is where the variable is. So you're going to do that same idea. You still have to do the whole minus the part to find the other part, but you're going to have to write that as an expression. So you're going to, this section right here that we need for the method 1 proportion, you're going to have to write x minus 2. That is representative of this length. This is the full length minus 2, gives you the remainder, which is the section. So you're going to have to label that piece and then write the proportion using the Splash Mountain rule. So it's going to be x minus 2 over the altitude, which is 3, equals 3 over 2. Then you cross multiply, so 2x minus 4 equals 6. Sorry, not 6, 9. It's too late. All right, so then you add the 4, so you get 2x equals 13. And then you divide by 2, so x is equal to 6.5. There you go. All right, so that one was a little bit weird in how you had to label that side, but it's always a possibility, so make sure you're looking out for that. Right, then we have one more right here where we have two variables, excuse me, in one diagram. Let's see if they are related to each other or if you can solve for them separately. So for x, that is the altitude, so I would be using method 1 to solve for that. I have all the information I need to draw the arrows and solve. Y is a leg, so I'd have to use roller coaster rule to do that. I have all the hypotenuse, the leg itself, and then the section closest to it. So I have all the information for either of them. They're not related to each other. I can go ahead and solve separately in whatever order I want. So let's say I started with x again, method 1. Draw my arrows in whatever direction you want. When I write the proportion, it'd be 6 over x equals x over 5. Right, and then you cross multiply, you get x squared equals, excuse me, 30. 30 is not a perfect square, and you can't simplify it. So once you get x squared equals 30, you would take the square root, and you would, excuse me, you would just get the square root of 30 as your final answer for x. All right, switching to y, again, this is a leg instead of the altitude, so I will be using the Splash Mountain. Nope, sorry, the roller coaster rule. I'm going to start as far away as possible. I'm going to launch across the hypotenuse, loop the leg, and then land right next to it, right here. I'm going to draw the loop. So the first part of the proportion, this launch section, is the full length of the hypotenuse, 5 plus 6, so that becomes 11. So it's this over y equals y over 6. And cross multiply, you would get y squared equals 66. Again, 66 is not a perfect square, and you can't simplify that as a radical. So when you take the square root of both sides to get y by itself instead of y squared, you would just get the square root of 66, and you would leave it be because it cannot be simplified. Right? So it's really just deciding which rule you're using, being able to pull it off and simplify everything correctly, or factor and check your work correctly. But that's ultimately all that this lesson is.